Question 4. Two solid spheres A and B are made from the same uniform material. The mass of sphere B is 3 times the mass of sphere A. Sphere A has radius small r, and sphere B has radius big R. What is the ratio big R divided by small r for objects made from the same material? So what do we already know? We know that density is defined as mass divided by volume. If two objects are made from the same uniform material, then their densities must be equal. We also know that the volume of a solid sphere depends on its radius and is given by the formula 4/3 pi small r cubed. Let us get into the solution now. First, we represent the masses of the two spheres. Let the mass of sphere A be m sub A. The problem states that sphere B has 3 times the mass of sphere A, so the mass of sphere B is 3m sub A. Next, we use the fact that the densities of the two spheres are equal. Since density equals mass divided by volume, we can write the density of sphere A as m sub A divided by v sub A, and the density of sphere B as m sub B divided by v sub B. Because the densities are the same, these two expressions must be equal, so we write m sub A divided by v sub A equals m sub B divided by v sub B. Now we substitute the volumes of the spheres. The volume of sphere A is 4/3 pi small r cubed. The volume of sphere B is 4/3 pi big R cubed. Substituting these into the equation gives m sub A divided by 4/3 pi small r cubed equals 3m sub A divided by 4/3 pi big R cubed. Next, we simplify the equation. The factor 4/3 pi appears on both sides, so it cancels out. The mass m sub A also appears on both sides, and cancels as well. This leaves the relation 1 divided by small r cubed equals 3 divided by big R cubed. Now, we rearrange the equation to isolate big R cubed. Multiplying both sides by big R cubed gives big R cubed divided by small r cubed equals 3. So big R cubed equals 3 small r cubed. To find the ratio of the radii, we take the cube root of both sides. This gives big R equals the cube root of 3 multiplied by small r. Finally, we divide both sides by small r to obtain the ratio, so big R divided by small r equals the cube root of 3. Evaluating the cube root of 3 gives approximately 1.44. Therefore, the ratio big R divided by small r is approximately 1.44. This is our final answer. What did we do? First, we used the fact that the two spheres are made of the same material, which means their densities are equal. Then, we wrote density as mass divided by volume and equated the two expressions. Next, we substituted the volume formula for a sphere and simplified the equation. Finally, we solved for the ratio of the radii and evaluated the cube root of 3 to obtain the numerical result. Here are the main concepts applied in this question. Free fall with no atmosphere means that the only force acting on the object is gravity. The relevant kinematics, or Suvat equation, for displacement under constant acceleration is s equals ut plus 1/2 at squared. When an object is dropped from rest, the initial velocity is 0,